Hi, my name is Zoe Valero, and I'm senior researcher at the Universitat Politécnica de Valencia in Spain. On behalf of the rest of authors and the whole Life Chance Project Consortium, I'm going to present the work entitled A Collective Intelligent Platform to Support Older Cancer Survivors towards the definition of Life Chance System and Big Data Reference Architecture. The presentation is organized as follows. First, a brief introduction and context is given. The second section describes the state of the art about big data platforms. Following section refers to the methodology followed to design the architecture. And the final section deals with the discussion. Cancer is a global public health threat. The risk to develop cancer increases as people age. It is now estimated that in 2035, 14 million new cases of cancer among older adults will be registered every year. That's double those registered in 2012. At the same time, many more older people survive cancer today thanks to more effective cancer diagnosis and treatment. Life after treatment can be complicated by challenges placed by underlying health conditions, uncertainty, or suboptimal follow-up care and support. This can adversely impact on quality of life. Life Chance aims to improve follow-up care for older people with cancer. For that, Life Chance will complement patient transition to life after treatment in order to enhance the supportive mechanisms available to patients and their families and help them to improve and maintain quality of life. In Life Chance, we will use state-of-the-art technologies in the fields of big data, high-performance computing, data analytics, and artificial intelligence to combine data collected from patients' reported outcomes, wearables, and ambient home sensors, and routine clinical information within a comprehensive system. Life Chance puts at the center stage of research efforts the exploitation of state-of-the-art big data technologies to design the best approach for data collection, cleaning, ingestion, storage, mining, models training, deployment, exploration, and visualization. Therefore, an innovative architecture was envisioned supported by the Big Data Value Reference Model with vertical and horizontal concerns and based on the Kappa architecture. The main premise behind the Kappa architecture is that it enables to perform both real-time and batch processing, especially for analytics with a single technology task. It supports near real-time analytics when the data is read and transformed after it is inserted into the message engine, making recent data quickly available for end-user queries. In this context, it is important that any system addresses the end-user's expectations, needs, and requirements. For this to end, an iterative and co-creation approach was followed to collect end-users' inputs and transform them into the Life Chance system description and design. Thus, this feedback was translated into technical and functional requirements, crucial for the development of all the system components. To answer such ambition, supporting an integrated approach and ensuring all the pieces fit together, a reference architecture should be provided with the standard and guidelines, together with the Life Chance system characteristics. The 4+1 architectural view model was chosen for the Life Chance architecture. This model represents a simplified description of a software-intensive system architecture based on the use of 5 simultaneous visualizations. The diverse views correspond to different perspectives of stakeholders, such as the end users, developers, system engineers, and project managers. The Life Chance system targets older adult cancer patients caregivers, and also the health professionals, with a comprehensive solution capable of offering tools and mechanisms to promote patients' empowerment and improved quality of life via timely and more accurate clinical decision support. To this end, the lifetime system is composed by its actors, that are the lifetimes platform, the aids, which includes everything deployed at patients' homes, and the data warehouse. Concretely, the lifetimes platform comprises all the central components and services of the lifetime system. It is the end-user applications, the computation components, the analysis components, and also the transversal services to satisfy the system requirements. Regarding the lifetimes architecture, the four views of the model are the logical view, showing the functionality, the development view for the code base, the process view, presenting the communication between services, and the physical view, including the implementation of its services. In addition, there is one more view called use case or scenarios that is used to illustrate the whole architecture. Concretely, the logical view is concerned with the functionality that the system provides to end users. It includes the main components of the lifetime system from the point of view of the end users. Overall, the system delivers and collects information to and from the end users through the two end users applications that are the dashboard and the application for quality of life assessment, as is shown in the diagram. The Lifetimes platform integrates the groundbreaking technologies in big data and artificial intelligence towards delivering a smart, personalized, and secure platform for analyzing health outcomes and addressing comorbidities of older adult cancer survivors by preventing long-term effects and improving quality of life. The aid is responsible of managing the components deployed in the patient's home, such as the sensors and the information they collect. Finally, the data warehouse component is responsible of the secure storage and integration of data from multiple and heterogeneous sources. The process view considers non-functional requirements. It shows processes of the system and how they communicate with each other. The architecture description includes the process view diagrams with the user stories associated, showing how the different processes communicate among them for all the system components of the Lifetimes platform and architecture. The figure includes an example representing a registered healthcare professional who wants to access to the analytics of a site through the dashboard component. The development view illustrates a system from a programmer's perspective and is concerned with software management. It shows the most relevant building blocks of the system. Following the previous example, these diagrams presented in this slide represents the component and the package details for the dashboard component also. Regarding the physical view, it depicts the system from a system engineer's point of view. It is concerned with the topology of the software components on the physical layer, as well as the physical connections between these components. The components that contribute to this view are the patient sensors, the end user application, the home location sensor, the high performance computing, the edge storage, and the data warehouse. This +1 view of the model called scenarios consolidates the other views. The elements in the four views previous shown work together seamlessly by the use of a small set of important scenarios. The scenarios are in some sense an abstraction of the most important requirements. From the healthcare professional perspective, the proposed scenario in this diagram shows how a user is completing the goal of analyzing data for the dynamic modeling of patients, as is presented here. The system and architecture presented will collect biometric and psychometric information from patients, will combine previous data with other sources such as electronic health records in a secure storage, and will rely on data analytics and artificial intelligence for the computation and analysis of such data. Hence, establishing the best models for different geriatric, quality of life, and symptom measures from a dynamic perspective. The system will rely upon the LifeChance platform and the high-performance computing big data infrastructure. These outcomes will be assets in 4 pilots in Greece, Sweden, Spain, and the UK. Thanks for your attention.